Alright, so first we're going to start off with a review of what quadratic functions are and how they look. Generally, we only use the general standard form, but it's not unlikely also that you may use the vertex form. It just doesn't come up as often with what we do in Algebra 2. Now, if we look here at A, B, C, K, H, okay, there's all of these constants here. And if I actually look at what this is asking me right here, you might want to pause the video for a second and see if you can answer that question. But if you can't, then what you're looking for is why a can't equal 0. Well, here, a multiplied by something squared would not make it squared anymore. And here, a multiplied by something squared would not make it squared anymore. For instance, if I have ax squared, and then I know that a is 0, well, that's saying I have 0x squared, so I would end up having just 0 anyways. Okay, hope that makes sense. Then down here it actually has the characteristics. So for instance, on this first one, it says the vertex. This is how you find the vertex in standard form. Okay, you would use negative b over 2a right here. And then you would plug that in to find the x value, and then you'd plug that in to find the y value. Okay, and we'll go through how to do that here in a minute. But just so you know, the vertex is this point right here where the graph starts to change its curve. Okay, and then it says axis of symmetry. Well, on standard form, again, we see that the x, the axis of symmetry is that line that goes through the graph and where it mirrors itself. When we do a quadratic graph, it makes the parabola, right? And then on one side has to match the other. That's kind of sloppy, but I hope that makes sense. Okay, so further down, y-intercept is 0 and c. In other words, when you get a quadratic formula, it comes in this form: a times x squared, b times x plus c. And that c is actually how you find your y-intercept. Okay? The rest of this I'm not going to go over just yet because it's not necessary, except for vertex form. If you look here, the vertex is found by h and k. Well, whatever my h is and whatever my k is, that should make sense for vertex form. That's why it's called vertex form. If we get a quadratic formula like this, the vertex is actually already written for you, and that's why it's called the vertex form. Okay, let's see. These two things I'll go over later. This one you're going to need a graphing calculator for, but we don't even use this method. I use a different method because it works better. Okay? So for instance, down here, I'm going to go through these examples with you. Okay? I'm actually going to stop the video here, and then that way you can have two videos, but you can get kind of an idea of what we're starting with. And I'm actually going to send, you'll also have, your version of the notes already filled out for you, but I want you to watch these so you can understand what's happening.